Hey there, interwebs. Back in September, I solved a math problem I created that I call the Christmas tree problem. I'm an Eagle Scout, and my home troop sells Christmas trees as our annual fundraiser. Each year, we order about 1,200 trees, but we don't have space to set them all up at once, so we put 300 on stands and pile the rest in the back. When one sells, it's replaced with one from the pile. This process repeats itself until all the trees are sold. Once we have fewer than 300, we stop refilling the empty stands. The problem is this. Is there an ideal time to come buy a Christmas tree? First, we need to make a few assumptions. The first is that there is only one type of tree. In reality, we have Douglas and Fraser firs as well as oversized trees, but for the sake of the problem, let's just say they're all one type. The next assumption is that everyone can agree on ideal qualities so that there is one objectively best tree. Some people like taller, some like shorter, some like bottom heavy, others like bushy at the top, but here everyone wants that one perfect tree. Last, we assume that the trees are organized and put out on stands randomly. This is actually pretty true to life. Now let's examine the problem. When the first customer arrives, there are 300 trees to pick from and they'll pick the best tree available. This will be replaced with one from the pile. The replacement is either better or worse. If it's better, then it's the new most ideal tree, and if it's worse, it might still be better than second best and is therefore the new best, even though it's worse than its predecessor. If it's worse than second best is the new best available and that one will sell and be replaced. If its replacement is worse than what was originally third best available, that becomes the new best choice. This process continues until the pile is depleted and there are only 300 trees remaining, all on stands, and the rest have been sold. Anyone who buys a tree at this point is guaranteed to get the best tree available since there are none left on the pile that could be better. This sounds good, but once there are fewer than 300 trees left, they are guaranteed to be the worst. Once we're down to the last 299 trees, they're the worst because all the better ones have been selected out. The last tree remaining will be the absolute worst, the Charlie Brown special, since all others were bought and everyone bought the best tree they could. This conclusion isn't too hard to arrive at. In fact, most of you already knew this if you've ever gone tree shopping too late. It's obvious no one wants to buy the scrawny twig, so it will be the last one to sell. The problem is we don't care about the worst one available, we want the best tree. If you're the first customer, no trees have been sold yet, but you still only have a 25% chance of getting that perfect tree because 3/4 of the total lot are still on the pile. On the other hand, if you show up when we're down to the last 300, your odds of getting the best tree are surprisingly still the same 25%. This is because when we have 301 trees, one is on the pile, and that could be the best tree, so when the 900th tree sells, the last tree on the pile comes out, meaning the last 300 could potentially contain the best tree. Anytime between opening with 1,200 trees and the last 300, you will always only have a 25% chance of getting the best tree because the sum of the trees in the pile and the trees sold will be 900 or 75% of the total population. Of course, most of us don't care if we get the best tree, we just want a good enough tree, which I will now define as above average. This means it's time for statistics. Setting the total number of trees as our sample population and assuming a normal distribution for quality, half the trees should be above average and half below. If the stands are truly being filled randomly, then they should be a representative sample of the entire population with 150 trees above average and 150 below. As trees are selected out over time, the mean quality of the remaining trees decreases, and so you are more likely to get a less favorable tree. Once 600 trees, or 50% of the total, have been purchased, the remaining trees should be below the original average. Of course, since this is statistics applied to the real world with random chance, there's still a non-zero chance of there still being above average trees, even 50% likelihood that the best tree is still unsold. As before, your odds of getting a tree you would be satisfied with don't reach zero until fewer than 300 trees remain, but it's clear to see that they do decrease the longer you wait. In summary, there is a non-ideal time to buy your tree when there's fewer than 300 trees remaining for sale, but there is no ideal time due to the random nature of trees becoming available. If you take one lesson away from this interesting mathematical puzzle, let it be this. It doesn't matter when you're going to get your tree, but don't wait too long. No, wait. If you take one lesson away from this interesting mathematical puzzle, let it be this. Buy your tree from Boy Scout Troop 272 at the corner of Rose Valley Road in Brookhaven. Thanks for watching, and happy Hanukkah.